talk about non-metals in the periodic table. Let's start with group 7 or group 17. Some of your schools will talk about it that way. Basically, that is the group that's called the halogens, okay? The halogens, group 7 or group 17, actually consists of the most reactive non-metals that you can find in the whole periodic table. And they're not called the most reactive for nothing. These gases can kill. So it starts with fluorine, it goes down chlorine, then bromine and iodine, and so on and so forth. All the elements under group 7 or 17 actually have 7 outermost electrons on the outermost electron shell. And they are very reactive. They are also pretty powerful oxidizing agents. You will learn that more under the chapter of redox. What are some of the simple properties of group 7 elements that we can say? Well, one thing for sure, if we go down the group, their color definitely gets deeper and deeper. Fluorine gas is colorless. Fluorine gas is green-yellow. Oh, got a little bit of color, right? Then bromine is red-brown as a liquid. Iodine is actually very strong purple, and very, very popular question. Therefore, people will ask you, so what do you think is the color of astatine? So if you already know the trend that going down group 7 means that element gets deeper in color after deep, strong purple, the next one, naturally, everybody's going to say black, and that would be an acceptable answer. Now, likewise with the metals, as you go down the group, the molecules get bigger and therefore it gets heavier. So the melting boiling points again will increase and the density will increase. That's why if you are looking at the state of group 7 elements, the halogens, what you would notice is you'll notice that they started with pretty low melting boiling points. That's why they were all gases to start with. Then as they go down, bromine is where they become liquid at RTP. Then after that, it's all solids at RTP. Most definitely has an increasing effect on the melting boiling points of the halogens and the densities as you go down group 7. There's one other thing that group 7s will do, which all the other non-metals cannot follow, but group 7 can. Group 7 will actually mimic what the metals do. They do displacement reactions. What do I mean by that? The more reactive group 7 element is able to kick out the less reactive group 7 elements from their compounds. Sounds familiar? It sounds exactly like what we said for the metals, doesn't it? Which of the group 7s are more reactive and less reactive? Well, group 7, the most reactive will be fluorine. Right at the top, they are the most reactive. And as you go down the group, they get less and less reactive. So astatine will be significantly less reactive than fluorine, which is a crazily reactive gas. I hope you do notice this is the opposite trend to metals. Metals, in my previous video, I told you, metals as they go down the group, they get more and more reactive, right? Non-metals, especially for halogens, that's the opposite. They start with the most reactive halogens right at the start. As you go right down the group, they get less and less reactive. The topmost group 7 elements can easily kick out the halogens of the lower down halogens from their compounds where they exist as halides. For example, let's talk about this. Chlorine gas reacting with potassium iodide solution, iodine being a lower down group 7 halide, right? So what happens is that chlorine, being more reactive, will be able to kick out iodine and take over potassium, which gives you chlorine gas plus potassium iodide produces potassium chloride, taken over already. Potassium chloride plus iodine. This is one of the most popular chemical reaction to showcase displacement for group 7s. I hope you can remember this, and please click like if you like the lesson, and I hope you join me on my channel. I got my head out the sunroof, I'm blasting